Alright, let's start. Doctor. Alright. So now, so this is the circuit, okay? So we call it, so the one that you've experiment, okay, previously. So we call it ladder circuit, right? Ladder circuits. So in ladder circuit we have, okay, in this example we have 6 resistors, okay? We have R1, 1 kilo. We have R2, 2.2. R3 is 3.3. We have R4, 6.8. R5, 10 kilo. And then we have R6. So in the table, in these two tables, what we need? Let's try to write what value do we need, okay? So we need what? VA, huh? From the table, we need VA. We need what? VB. We need, sorry, VC. Sorry, we need what? VD. What else? Current, or the current through R1. Let's see. Let's call it IR1. Okay. The current through R2. The current through what? R4. And the last one, the current through R6. Right? So 1, 2, 3, so we have 8. Okay? 8 things we need to measure. Or 8 data we need to measure. Alright? Now, by looking at the circuit, okay, let's identify where is this unknowns, huh? VA. So we have the ground here, right? We have the ground here, connection. Alright? So, VA means, VA, if you want to measure VA, what's that? Here. VA. Right? VB, VC, and we have VD. Agree? Alright. Now, look. What I'll tell you, okay? Look, huh? VA. Let's see. Let's start with VA. VA. So, VA is what actually? Is actually what? VA is actually what? The voltage what? Across the source. See? Look. You see it? What you are actually measuring here is the source. So here, we can say that VA is equal to V source or E. Huh? Equal to E. And that is what? How much? 20 volt. Ano directly. So, lala. Okay? Next. BV. How about BB? BB, what? BB is the voltage across what? Yes. So, if you try to look carefully here, BB is this point, right? And the ground and this point. The one that you did in the measurement. Okay? And what you are actually measuring is what? Look, this is the same point, correct? BB. What you are actually measuring is the voltage across R2. So meaning we can say here that VR2 is just equal to BB. So and by calculations, now the next question, can we calculate this using Ohm's law? Or much better, Kirchhoff's or divider? Divider. I think the best way here is the divider rule. Easy. The easiest way to calculate is the divider rule. Okay, how? So we know VR2 or VV, VR2 is just equal to this. Alright? So by applying the divider rule, so how we apply the divider rule here? What's the formula? That's by the formula, by the general formula, VR2 is just equal to R2 R total by general rule, divider rule, multiplied by B source or E. In this case, we have E here. Okay? We have here E. Is that correct? Okay. So R2, R total, E. Do we have E? We have E, right? Do we have R total? Not yet. Not yet. Okay? we need to calculate R totals, huh? Do we have R2? R2 is this one, but make sure later, I will tell you. This is not the actual R2. Alright? I will tell you later, okay? So, but first, let's try to calculate R total. Okay? So, R total, how you calculate R total? So, we'll start with resistors R5 and 6. So simplification, right? So we need to get first R5, 6. So that would be series or parallel? Series, right? So that would be R5 plus R6. Simple as that, correct? So we have 10 kilo plus 22. Correct? So how much? 32 kilo. Correct? Please prepare your calculator. Alright? So that will be R5, 6. Next. So this together now become one resistor. So now this resistor R5, 6 now, these two is in what? In parallel now with R4. So it's in parallel. So meaning here R4, 5, 6 would be what? Formula, give me the formula. R4 multiplied by R5, 6. Is that correct? Divided by R4 plus R5, 6. Agree?
Yes.
Agree? Okay. So, what's the value? R4 is 6.8 kilo multiplied by 32 kilo. Is that right? Over 6.8 kilo plus 32 kilo. Sorry, 32 kilo. Come. So R4, 5, 6 is 5.6 kilo. 5.6 kilo. So now what we have? These three are now in one resistor. Okay. Next, again series with R3. So now we can say that R3, 4, 5, 6 is equal to R3 plus R. So R4, 5, and 6. So that would be equal to what? R3 is how much? 3.3. 3.3 kilo plus 5.6 kilo. How much? 8.9. So next we have this R3, 4, 5, and 6. Next, again, so this one is now series, again parallel to R2. So R2, 3, 4, 5, 6, we can say, that would be R2 parallel, multiplied by R3, 4, 5, 6 over R2 plus R3, 4, 5, and 6. The value R2 is 2.2 kilo plus sorry multiplied by 8.9 kilo over 2.2 kilo plus 8.9 kilo. So that's R2, 3, 4, 5, 6. How much? Huh? 1.60? Sorry, 76. Sorry, 76 kilo. Kilo, huh? So therefore, the last one, R total, right? So we now arrive. Okay, we can get now the R total since that's the last part. Series, right? R1 is series with this one. So R1 plus R2, 3, 4, 5, 6. So that's 1 kilo plus 1.76 kilo. So we have finally the R total, how much? 2.76 kilo ohms. Okay? 2.76 kilo ohms.
Can't get this.
No, you can. Okay? Later we can. Okay? So that's 7 point. Oh, sorry. R total is 2.76. So now we go back. So now let's go back here. So BV now is equal to VR2. Alright? Which I showed you before, right? Now, the formula, general formula for voltage divider, R2, so since we are after R2, that's R2 over R total by the source. So we have now E, 20. Now R total, we already have the R total. What we need now to do is to get the R2. So where is R2 now? Is this the R2, 2.2? Huh? Is this the R2? Are you sure?
No, R1 plus R2.
Which? Again?
R1 plus R2.
R1 plus?
R2.
No, R2. I'm asking about the R2. The real R2.
The number?
The value of R2. The value of R2 here. Is this value that one, R2, from the formula?
No. One is 1.76.
1.76. Why?
Because all the same.
Yes. See?
Ah, you mean the
You get the
number.
point?
Okay, okay, yes.
You get the point? See? Actually, the R2 here, okay, is this whole part. See, because we are applying the voltage divider rule, right?
Yeah.
Okay, voltage divider rule by two resistors. If you say VR2 by two resistors, that is R2 over the R total, R1 plus R2 sa multiplied by the source. So meaning here, okay, the meaning here, this is equal actually, the real VR2 now, or BV, is just equal to R2. What's the R2? R2 is actually this value. R2, 3, 4, 5, 6. The resistor, these 5 resistors, is actually the real R2. Take note, when you apply the voltage divider rules, over the R total, which is what? R1 plus R2, 3, 4, 5, 6. It's something like this. It's something like this. Wait, look. Because the last circuit that we have is this one.
You have to.
Right? Okay. So this is R1. This is R2, 3, 4, 5, 6. Is that correct? So when you apply the divider rule, since we are after this one, which is point B, here, we are after this one, VR2. Okay? Before. BB. Right? So the voltage here is the resistors, the value of the resistance over the total in series, okay, multiplied by the source, which is here. Is that correct? So meaning here, VR2 is just equal to what? Where is R2, 3, 4, 5, 6? This one. 1.76 kilo over 1 kilo plus 1.76 kilo multiplied by 20. That's the real VR2 or the voltage across point B or node B. We call it node, right? So how much is the value here, Bob? Huh? 12.75 volt. That's BB. Same thing when you apply what? When you are after what? B what? BC. So now, be careful again with BC, huh? So you are after now BC, which is this one, huh? when you apply the voltage divider rule, okay, what should be the case? What should be the formula now? So VC, actually, VC is just equal to V across what? R4, actually, V across R4. But by applying the rule, what actually is there? Up. Huh? R4.
Not the R4.
Not the R4, but it's what? This three.
R4, R6.
Yes, it's R456. So it's something like, before it was here, and this one. Now this one now, since we are after R4, these three now all together, plus this one, right?
Yeah.
So VR4 will be V R 456. Is that correct?
Yes.
Over what? What's the resistance?
R3.
R total. R3
Plus
plus.
R4, R6.
Yes, R456 multiplied by the source.
Source, not the source.
Not this source, right? Not this source now.
12.7.
What is the source now?
12.1.
Yes, because now this becomes the source.
Okay.
The voltage across BB,
The new source.
the new source. See? It's like a pattern, no? It's like a pattern, right? So that would be B across or BB. That's what BB. Is that right?
Yes.
Clear now? Are you getting it now? Are you following? Can you follow? It's not. Yes. What? Yes. No. It's okay. It's still okay. Still okay. Yeah. It's still okay. All right. All right. Still okay. Now. All right. So now let's see. How much now? How much? Give me the value. How much?
5.6.
So that's R456. Where is it?
5.6.
5.6 kilo. R3 3.3
3.3 plus 5.6.
plus 5.6 multiplied by BB. How much?
12.75.
12.75 volt, right? So what's now VC or VR4? Come 8.02 volts. All right.
Yeah.
Double check with your table, please. Double check. Is it the same? Are we getting the same value? Are we getting the same value? Almost close. Almost the same. Please check. Good.
Yes.
So far good.
Yes.
So far good. Are we getting the same number? Good. Next. The last one is so simple. The last one is so simple because see, it only consists of these three resistors. So it's much easier now, right? So same thing. Yeah, just moving, no? Pattern, like a pattern, right? So BD now is actually what? Equal to what? BD here is actually the voltage across R6, correct? So that would be voltage across R6, and that would be now what?
R6.
R6, because there's no other resistors here.
Yeah.
Alone, R6, you know. That's it, okay? R6 over,
R5 plus
yeah, these two resistors again, series, right? R5 plus R6 multiplied by, what's the new source?
8.2 DC.
VC, yes, it's VC now. Right? This is now the new source. See, it's like you just adjusting it, right? Correct? So now that's VC. So now this one, R6, come. 22 kilo over R5. Which R5? 10 kilo plus 22 kilo multiplied by VC, which is 8.02 volts. So VD now, which is VR6, how much the value?
5.5.
5.5 volts. Check again. Same? Same?
Okay.
Good? Okay, good. So we have now VA, BV, BC, and BD. As you can see. So next, what we need? Current. No, I think it's easy now because we had the voltage now. It's very simple. By simple Ohm's law, we can apply simple Ohm's law rule, right? So IR1. Let's try IR1. So IR1 will just be equal to, let's say, applying Ohm's law, right, for current divider rule here. VR1 sa
After.
over R1. Is that correct? So that would be
The I want is equal to I don't have because the current is slow.
yes,
Same number.
correct. So meaning IR1 here is just equal to, yeah, correct, you're right. IR1 here is what? The current through R1. So that is just equal to what? I total, correct? Because this is the line right here. Okay. The I R1 is here, which is just similar to what? The I total. Correct? Okay. So how? That's B total over
After.
R total.
Yeah.
What both? So that would be 20 volt over, is it 20? Yes. R total, which is R total? 2.76 kilo. So how much is the IR1?
20 volt.
Come?
7.20
24 milli.
Yes.
The next we have IR2. So where is IR2? Let's identify first with R2 here.
Yeah.
So do we have the voltage here? Yes, we have VV. Right?
Yes.
So you can simply calculate it. VR2 over R2, and this, you know that this one is equal to BB, correct? That's BB. So how much? VR2 or VB? VB 12.75 volt over 2.2 kilo R2. So how much is IR2? 5.8 milliampere. So as well now with IR4,
Yeah.
IR4 is actually, okay, VR4 over R4,
Yes.
and we know that R4 is the same as VC,
Yeah.
correct? This is just the same as VC, correct?
Yes.
So that would be how much? VC 8.02 volt over R4. R4 is
0.8.
6.8. Okay, so IR4 here is equal to, come,
1.20.
1.17
11.
milliampere. And finally, we have IR6. That's equal to VR6 over R6. How much? VR6 is actually equal to VD, right? Is equal to VD. So that would be VD. How much is VD? 5.5
Yeah. 5.2.
over
22.
22 kilo. So IR6 is just equal to
0.25.
0.25
11.
milliampere. Alright, so we have IR1. We have IR1 now here. We have IR2. We have IR4. Then we have IR6. Please check. Is just the same? Is it the same? Same number? Any question? Good? Clear? Is it clear?
Couldn't guess it.
Okay, I think the number is clear.
Send na test lang. Kan man marunong.
Okay.
كويس نص على البسمة.